Welcome to the third webinar from the series about Allplan Bridge solution. In today's webinar, we will detail and reinforce bridge model which was previously prepared in Allplan Bridge. On the same railway bridge with a length of 160 meters, we will show you how to create the library elements in Allplan Engineering and to complement the bridge model with smart placements. We will also model the abutment of the bridge in Allplan Engineering, and then we will go into details and create the reinforcement for each element of our bridge. Let's start with creating the library elements in Allplan Engineering. In the previous session, we already showed you how to place vertical elements of the bridge barrier by using the Smart Placement option from Allplan Bridge and saving those elements in the library palette in the project folder of Allplan Engineering as a smart symbols. Here we already prepared another element. This is an anchor element which we predefined by using the task area engineering structures and the function tendon. This function we can use to create the anchorage elements for pre-stressing tendons for the bridge and civil engineering components. By using different tabs under this tool, it is possible to define the parameters like sheet, trumpet, spiral, anchor plate and anchor object according to the user needs. In the next steps, we will manually create two additional elements for a project library, bearings and couplers. For this, we will go to the building structure by double-clicking with the left mouse button, and under the project we will insert a new structural level as any structural level and assign to it several drawing files. Under the activated drawing file with the name Smart Placements, we will start to model bearing element. For this, we will use different modeling tools available under the task area modeling. We will select the task box and start to model the box based on the diagonal line freely positioned in space. We will enter the necessary dimensions and the height, and after that we will use the tool chamfer edges and chamfer the top edges of the box for 5 centimeters. After this, we will select the extrude tool and extrude the top surface of the existing box by using the offset and creating the new element. We will repeat the extrude function by entering the other offset and also creating the new element. When those three elements are ready, we will use the option copy and mirror and copy two bottom elements around the axis of the top box. With that function, we will finish the modeling of the bearing element. Using the Insert Element New Smart Symbol option, we will create a new smart symbol with a wished name, which must correspond to the name given to the reference point in Allplan Bridge, which will be used for the smart placement. After that, we will define the new foil by selecting the 3D element, and we will also define the smart symbol reference point, which will be used as an insertion point for this bearing. We created the bearing on the left side, and since the bearing on the right side looks the same, we will copy the existing elements and change the name to the bearing right. In the next steps, we will create the coupler element. We will start by selecting the tool 3D surface from the modeling task area in order to create the polygonal 3D surface with the thickness of the metal sheet of the coupler. After 3D surface is created, we will use the tool Revolve in order to create the 3D solid by rotating the existing 3D surface around the imaginary axis of the coupler. With this, coupler element is ready and it can be defined as a smart symbol and saved in the project library of Allplan Engineering. With this, all the wished bridge equipment elements are saved as smart symbols, and they are always available in the library folder of Allplan Engineering, where they are saved as NMK files which contain the individual smart symbols. Those files can be exchanged between the project members. In the next step, we will go to Allplan Bridge and define the missing smart placements. Under the Bridge role and Parametric Modeling task area, we will use the tool Start Allplan Bridge to start Allplan Bridge directly from Allplan Engineering. In order to parametrically position bearing elements in Allplan Bridge, we will go to main girder cross-section and define two new reference points with the names bearing L and bearing R, and for each of them we will define a new dimensionless variable with which we will define the positioning of the bearing in the longitudinal direction. In our last step, we will go to the variation table of the main girder, and in the corresponding column for each variable, we will enter the number 1 in the stations where we want to have the bearing. This will be on the positions of all the piers and the abutments. All those positions are visible in the 3D model as well. The workflow for positioning the anchors and couplers at the end or the beginning of the tendon elements is a bit different. For this, we need to go to the Tendon Geometry menu or to the Analysis task, and under the Tendon Stressing tab, we can multi-select the tendons from one group or from the several groups, and on the right side of the screen, in the Properties window under the Placement menu, we will define the anchor at begin or at the end as well by defining the names of the elements from the Allplan Engineering library. In this case, we will enter the names coupler and anchor. After all definitions are done, we will recalculate the project in Allplan Bridge and return to Allplan Engineering in order to complement the bridge model with smart placements. We will go to the building structure, deactivate the smart placement drawing file, and activate the complete bridge model by setting the main girder drawing file to active. After that, we will go to the parametric modeling task area and update the Allplan Bridge data. After the update is done, all defined smart placements connected to the library elements and the smart symbols will be available on our 3D bridge model and placed on the wished places. After the bridge equipment is placed, we will for this example model the abutment in Allplan Engineering in order to show you the powerful functionalities of modeling. We will start with organizing the building structure. We will create two new structural levels, stories, and name them Abutment 1 and Abutment 2. To each story, we will assign several drawing files. We will assign drawing files with the series 100 to the Abutment 1. To the Pier 1, we will assign 200 series, Pier 2 300, Pier 3 400, and to the Abutment 2 500 series. At the end, we will activate Abutment 1 first drawing file 100 and set it to active, and also main girder part. With this setup, we will start with the modeling of the abutment. We will start to work with the 3 different viewports with plan, elevation, and the animation window. On the left side of the screen under the Objects palette, the complete bridge model imported from Allplan Bridge is structured into the different elements like 2D elements, 3D curves, and 3D solids, and here it is possible to do the partial selection as well as to set the visibility of the elements. For this purpose, we will set the smart symbols to invisible. Under the modeling task area, we will use the available modeling functions to model the 3D bridge abutment. As a first tool, we will use a 3D surface in order to create rectangular 3D surface using the diagonal points. For creating the 3D surface in 3D, we will use the tracking options and also entering the points by using the coordinates. We will create the rectangular 3D surface 5.5 times 6.1 meters and use this 3D surface to extrude it in the next step. We will extrude this surface as a new element, going downwards for approximately 6 meters. After that, we will use the extrusion function to extrude the rectangle as a new element from already existing 3D body. We will use the inner surface of this solid in order to extrude the rectangle with the dimensions 5.5 times 6.1 and the height of 1.75 meters. This element represents the beam onto which we will support the bearings. We will again use the extrude function and extrude with the rectangle already existing 3D solid. We will use the plan view in order to easily define the dimension of the wished rectangle, and then we will extrude it going upwards, and in that way we will deduct this area from the already existing 3D solid and we will create the wing walls. The thickness of the wing walls is 50 centimeters. After deleting the 3D surface, which we don't need anymore, we will continue to detail the wing walls. For this, we will again use the extrude function. We will use the option extrude polyline and draw the polyline on the outer surface of the wing wall. After that, we will extrude this polyline along the wing walls, and with that we will deduct this volume from the existing wing wall dimensions. After the wing walls are created, we will use the extrude rectangle function and create the foundation with the dimensions of 7.1 times 9 meters and with a height of 1.5 meters. For this, we will extrude the bottom surface of the existing beam element. As a last step of the 3D modeling of abutment, we will create the piles. For this, we will use the extrude function and extrude the circle from the bottom surface of the created foundation. By simultaneous work in the plan view and in the animation window, we will create one pile with a radius 0.35 meters and a height of 6 meters. After first pile is created, we will copy it 5 times in order to get 6 piles in one row. In the last step, we will copy all 6 piles 2 times, and in that way we will have 3 times 6 piles for the foundation of the bridge abutment. When the first abutment is created and modeled, we will use the option copy and mirror in order to copy it and mirror on the other side of the bridge and create the abutment too. When the bridge model is completed, we will create several cross sections and longitudinal section of the bridge. As a first step, we will set up the building structure. By double-clicking with the left mouse click, we will open the wished window. On the left pane, we can see the building structure, and on the right pane, we can see the elements derived from the building structure as views, sections, and reports. Under the sections, we will insert the new section structural level and assign several drawing files to it. We will name the first drawing file sections and set it to active, where the complete bridge structure from the left side will be set to edit mode. By pressing the combination of Alt and 3 on the keyboard, we will return to the 3 viewports. For the purpose of section creation, we will start to work only in plan view. Under the reinforcement task and the sections task area, we will use this group of tools in order to create the sections of our bridge model. It is possible to create a section and the view. We will select the Create Section option. After that, the new palette will appear on the left side, and we can choose between the basic and advanced input and between the horizontal or the vertical section creation. We will create a vertical section with the basic input. The first step in a section creation is the selection of the view or section from which we want to make the section, or just the direct creation of the clipping path by clicking with the left mouse button and selecting the first and the second clipping path point. After that, we will press Escape and decide about the depth of the section and the viewing direction. This can be defined with exact measures, as in this case 50 centimeters, on the outer side of the abutment. Before the section is placed, but also afterwards, it is possible to adjust different settings according to the user wishes, as for example the labeling as an additional text for the title of the section, or some settings of the formats, which means that we can decide about the elements which will be represented and visible in the section. After the section is defined and placed, it will have two frames around it, one called section and the other clipping path. By double-clicking on the wished highlighted frame, we can open settings of the section or the clipping path at any time during our work, and additionally adjust the section according to our needs by adjusting the visibility or the labeling of the section. All the sections in Allplan Engineering are being updated automatically, and they reflect any changes which we are making in our model. Nevertheless, the user has always the option to switch this option off and later to return to it if necessary. In the same manner that we created the cross section above the abutment, we will create all other sections of our bridge model. We will create one section in the middle of the first span and, of course, make additional settings according to our wishes. The next section we make is above the Pier 1. We will adjust the settings of the section and place it. After that, we will follow the same workflow and create additional sections above the Pier 2, above the Pier 3, and also above the abutment 2. The user-defined settings of the cross-section will be saved for all future sections which are being defined, so it is not necessary to adjust the settings each time. In order to create a longitudinal section of the bridge, we need to go to the engineering role, to the engineering structures task and the task area engineering structures in order to select the tool section along curve, which allows us to create a section along any 2D element in the plan. The bridge model transferred from Allplan Bridge to Allplan Engineering consists also of the bridge axis, which was transferred in the manner of 2D spline, which is available for us now in the plan view for a selection of the 2D element along which we will make the longitudinal section. It is necessary in the first step to select this 2D curve and to select or choose the direction view, after which the longitudinal section will be generated. This section consists also of pre-stressing tendons. After all wished sections are defined, we will start with the creation of dimension lines. Under the Quick Access task area, we can find the Dimension Line tool, which will give us the list of different available dimensioning options. Also, under the Draft role and Label task, under the task area dimensions, we can find different available dimensioning tools. We will select the Dimension Line tool and select the option Associative, which allows us to dimension only genuine points. There are different properties available directly in the tool. Here we can set different text, dimension text and arrowhead options. Beside that, we can go under the default settings options in the title bar and decide about the wished options related to the dimension lines. We will start with definition of the horizontal dimension lines. First, we need to define the position of a dimension line by clicking in the workspace, and then we will click the points that we want to dimension. To confirm the creation of a dimension line, we need to select the Escape key. By hovering the mouse over the existing dimension line, the software will automatically recognize the position of the new line. Using the same workflow and clicking the wish point, we will dimension the section with the several horizontal lines. After that, we will switch to the vertical dimensioning and dimension the section also in vertical direction. From the Quick Access task area, we will choose the Elevation tool, which will automatically calculate the height of the elements and place an elevation symbol with a label. In the next step, we will go to the Change task area and select the tool Change Architectural Properties. This tool is giving us the possibility to display and modify architecture-specific properties of some elements, 3D objects and 2D surface elements. By using the Shift keyboard key, we will multi-select several 3D objects from the section 1 and assign the same style area to all of those elements in the submenu Surface Elements. For the style area, we will select the Reinforced Concrete. To all selected elements, we will assign additional properties as a trade concreting work, material concrete C4050, and a calculation mode in cubic meters. All these assigned properties will be used later by the software to generate lists, schedules, and analyze the bridge data. Since the style areas have been assigned, we can now play with the drawing types at the bottom of our screen and assign the different drawing types in the working area, but also later for the layout definition. We can select from the list of the offered drawing types, but we can also create our own user-defined drawing types, and this part will be explained in the next webinar. By hovering the mouse over the 3D object in the section and by clicking the right mouse click, we will select the tool label and position the labeling to our section. This label consists of different architectural properties which we assigned previously to the elements of the section. By double-clicking the frame section, we will switch off the option Update Automatically, and in that way, we will make easier the selection of the points for the further dimensioning of the section, since the section has a depth and has many different lines hidden in the background. When we are happy with the dimensioning, we can return the section to Update Automatically option. In the further steps, we will finish the dimensioning of all the sections. In the next chapter, we will start with reinforcement modeling. We will first reinforce the pile cap element. We will begin with the section creation, which forms the basis for the reinforcement drawing we will create later. For this, we need to set up the building structure. On the right side, under the structural level sections, we will activate the new drawing file and name it Reinforcement Sections. On the left side, we will leave only the structural level Pier 2 in edit mode and turn off the rest of the structure. In order to create reinforcement, we need at least 2 orthogonal sections. We will create 2 sections in the plan view of the Pier 2, both with a basic input method and vertical. We will create a clipping path for both directions through the center of the pier. After the sections are ready, we will adjust the building structure. On the right side, we will set the reinforcement sections to edit mode, and on the left side, we will add in the Pier 2 structural level new drawing file with the name Pile Cap Reinforcement and set it to active. In the next step, we will define the new layer. The defined layers apply to all the drawing files in the project. The layer window can be opened by double-clicking with the right mouse button in the empty area or by choosing the tool Select Layers from the Quick Access toolbar. We will create a new layer under the folder Bridge and subfolder Reinforcement with the name Pile Cap Reinforcement. To this layer we will also give the short name. We will draw the pile cap reinforcement in this layer, and therefore this layer will be set to current, which is marked in red. The layers can be found in the Layers palette on the left side of the screen. Here the user has the possibility to control the visibility of the layers during work. We will now start with reinforcement modeling. We will use the reinforcement task and the bar reinforcement task area in order to select the bar shape tool, which we will use to define the bar's bending shape. The bar shape can be selected from the list and is also available graphically. For the first bar shape, we will select the closed stirrup and we will adjust on the left side in the palette additional parameters as diameter, concrete cover, and angle and the length of the hook. We will activate the option Expand to adapt the edges in order that stirrup will be forced to follow the edges of our pile cap. After that, we will place the labeling and adjust the labeling directly in the palette. The labeling can also be adjusted under the default settings options in the Quick Access toolbar. After this, we will use the input option Automatic Placement, and the software will automatically place the stirrups along the longer side of the pile cap. In the last step, we will dimension the bars in the plan view by adjusting the text, leaders and other parameters of dimension lines. By pressing Escape key, we can follow all the steps from Bar Shape tool which are embedded in this tool automatically. We can also escape some of the steps if we don't need them. In the next step, we will use the tool Modify Placement Display Mode, and we can adjust the bars displayed in the place reinforcement. We can choose between different display modes like showing the all bars, just a bar in the middle, and other options. We will choose to show just a bar in the middle for our stirrups. The place reinforcement has an immediate and direct effect on 3D model and also on all other views and sections. We will go to the Quick Access toolbar and select to work in two viewports in order to work simultaneously in 3D model and in section view. The stirrups placed previously are visible also in the pile cap 3D model. In the next step, we will place the longitudinal bars in the pile cap. For this, we will select the tool Bar Shape and select the straight bar shape. We will turn off the option Expand to adapt the edges and go to the plan view to select the wished edge by clicking the first and the second point of this edge, which will be followed by a straight bar. When we place the labeling of this bar, in the next step we have two options for the placement. We can switch on Automatic Placement option and let the software automatically place the bars along the edge. We can also adjust here the number of pieces and the spacing. On the other side, we can switch the automatic placement off and switch on the option Segment, where the straight bar will follow the segment which the user needs to select in the corresponding sections. We will select the bottom part of the stirrup and we will reinforce with the straight bars the bottom edge of the pile cap. Of course, we can adjust the spacings or the number of pieces of the bars according to the project needs. We can also adjust the visibility of the bars in the section by selecting the option to show all bars or just some of the selected bars. At the end, we will dimension the bars placed at the bottom of the pile cap. By using the tool Modify Placement Display Mode, we can adjust the visibility of the placed bars in the plan view as well. We can now use the copy and mirror function in order to copy the bars from the bottom to the top of the pile cap around the imaginary axis in the middle of the pile cap. We can also use different dimension line options in order to place the dimension lines for the top level of the reinforcement. In the next step, we will select the tool Place Bar Shape from the bar reinforcement task area in order to place already existing mark numbers. For this, we will select the bar from the bottom layer of the reinforcement and we will select the segment placement option. After that, we will select the left side of the stirrup and adjust the spacing between the bars. With this, we place the bars on the left side and we can also play with switching the sides if necessary while the command is active. We will place the labeling and finish all other actions which are necessary. After this, we will use the copy and mirror function in order to copy the placed bars from the left to the right side of the pile cap. By using the tools Modify, Placement Display Mode, Dimension Line Label and Label, we can finalize the reinforcement drawing for already placed bars in the section. In order to define the last layer of the reinforcement in the pile cap, we will use the option Bar Shape and place the open stirrups along all the edges of the pile cap. We will use the option Mirror in order to copy the open stirrup from one to the other side, and in that manner we will finish with placing the reinforcement in this element. In the final step, we will use the tool Partial Schema in order to show the schemas of the bars together with the text and prepare it for the documentation of the project. The schemas will update automatically and they will reflect any changes which we make in the placing of reinforcement or in the bending shapes. After the pile cap is reinforced, we will start with reinforcing the piles. In the first step, we will open the building structure and make necessary arrangements. We will create a new drawing file with the name Pile Reinforcement under the structural lever Pier 2 and set it to Edit mode and activate the drawing file Reinforcement Sections. We will choose the Section tool and make a new section of already existing section of the Pier 2 in the level of the piles. We will make necessary adjustments of the width for this section in order to see all 6 piles in the section that we just made. After this, we will return to the building structure and set the file Pile Reinforcement to active, all other set to inactive, and close the building structure. For the pile reinforcement, we will also create the new layer under the folder Bridge, subfolder Reinforcement, with the name Pile Reinforcement and with the corresponding short name. In the layer palette, we can set this layer to active or current and all other layers to modifiable. In the next step, we will select the Bar Shape tool in order to draw the straight bars of the piles. We will select the straight bar from the offered shapes and adjust the diameter, the hooks, and the concrete cover. We will switch off the option Expand to adapt the edges and draw the straight bar manually in the section where the pile is shown. When we enter the wished length of the bar, we will go to the next step and place the labeling, and with this, by pressing Escape, several times, we will escape the bar shape function. For placing the straight bars in the piles, we will use the tool Special Placement. This tool allows us to use the special mode Place in Rotation in order to place the bars by following the circle of the wished element. We will select the input option Circle, and after that we will follow the necessary steps which are written at the bottom in the command line. We need to select the center of the arc and the radius, and we will place the straight bars in the full circle from the starting angle 0 to the end angle 360 degrees. We can also set the number of pieces or the distance or the spacing between the bars. We can also adjust the number of pieces or the spacing between the bars. After we reinforced one pile and placed the labeling, we will copy the existing reinforcement to all other piles. With this step, we finished very efficiently with placing the straight bars in all 6 piles. In the next step, we will select the tool Circular Reinforcement, where it is possible to choose between circular and spiral reinforcement as a special bending shape. We will select the spiral reinforcement and adjust the diameter and other parameters in the palette on the left side. After that, we will follow the necessary steps offered in the command line of the software and define properly the parameters for the spiral reinforcement. After the spiral for the first pile is created, we will use the copy function and copy it to all other piles. This was our last step, and with this we finished with reinforcing the piles. In the next chapter, we will start with the definition of the pier reinforcement. We will start with defining the cross sections. For this, we will adjust the building structure. On the left side, under the structural level Pier 2, we will define the new drawing file with the name Pier Reinforcement and set it to Edit mode. And on the right side, we will set the Reinforcement section drawing file to Active mode. From the reason of showing you 3 different ways of reinforcing the complex pier shape with the stirrups, we will make 3 different sections of already existing section of the pier, at the top, in the middle of the pier and at the bottom. In each of them, we will, in the next minutes, show you different ways of defining the stirrups. When the sections are created, we will make the necessary adjustments of the width for the clipping path in order to see the full pier section in the created sections. And we will also, before we start to define the reinforcement, create a new layer as we did previously, but this time with the name Pier Reinforcement and the corresponding short name. We will activate this layer while drawing the reinforcement for the pier. We will also set to active the corresponding drawing file from the building structure with the name Pier Reinforcement. For this phase of the project, we will switch off the option Update automatically for all 3 sections in order to make the further definitions easier. After that, we will return this option to the default settings. In the first approach of defining the reinforcement in the complex pier cross-section, we will use the bar shape tool and the freeform reinforcement. For this, we will activate the options Match Edges, and also we will set all necessary parameters by the user wish in the palette on the left side. Using the Matching Edges option allows the user to create a freeform bar in one single step by matching the several connected edges. It is not necessary to click to the individual corners, and all you need to do is to specify the start point and the end point of the edge. This option gives the user great possibilities of drawing the most complex reinforcement shapes. In the second section, we will show you the next possibility of drawing the complex stirrups. We will use the definition of 2D objects like 2D line or circle inside of the cross-section with an offset equal to the future concrete cover, and finish the drawing of the inner line of the section following the shape of the actual section. When this part is finished, we will use the tool Convert Match Elements in order to create the bar's bedding shapes by converting the designed 2D entities into the reinforcement bars. It is possible to adjust all the parameters as the diameter of the future bars. In the last section, we will show you the final option of drawing the complex stirrup. We will select the bar shape tool and polygonal stirrup and adjust the necessary parameters in the palette. We will select the input option Expand to adapt the edges and simply adapt the edges of the complex pier shape. In this specific example, we find the last option the most simple one and the fastest one. Therefore, we will, in the top section of our pier, create the polygonal stirrup and use the input option Expand to adapt the edges in order to adapt the edges of our pier. After we created the first stirrup and label it, we will not use the placement option yet. Instead of that, we will draw all necessary reinforcement of the pier, which includes additional rectangular stirrup and longitudinal bars. We will again switch off the option Update automatically for easier definition of the bars in the section. We will define the additional 2D elements as lines and parallel lines in the section as a help lines for the definition of the bars. We will first define the closed stirrup in the middle of the pier, which will have the rectangular shape and it will match the wished edges. After the stirrup, we will start with the creation of the longitudinal bars. We will again use the tool Bar Shape and select the straight bar. This time, we will select the input option Straight Bar as a point and place the bar at the start of a fillet. We will simply place the bar in the section and we will also label it. We will escape the option of placing the bar in the section and create all other bars in the section of the pier by copying the existing bar on 1/4 of the pier section. We will use the option of multiple copy along the element in order to speed up the whole process. When we finish with the definition of all the bars on 1/4 of the pier, we will use the option of Copy and Mirror in order to copy the bars to the other fourth of the pier. After that, we will copy all the bars to the other half of the pier, and with that, we will finish with the definition of the longitudinal bars in the pier cross-section. To prepare the viewports for our further steps, we will go to the Objects palette and exclude 3D solids from the preview. In order to place the pier reinforcement along the pier height, we will go to the Freeform task area and select the tool Sweep Bars Along Path. In the first step, it is necessary to select the bars in the section, and then we need to set the parameters in the palette. After that, we will go to the plan view and select all the paths along which the reinforcement should be swept. It is of course possible to select those paths as 3D lines also in 3D view, but this way we are showing now it's faster. If you have any difficulties in selecting the parts in 3D or in plan like now, you need to hold the Shift key from the keyboard while you are selecting. All the 3D splines which we use as a parts now have been exported automatically from Allplan Bridge together with the bridge model. Since we are sweeping transversal and longitudinal reinforcement by using only one cross-section, just to be more precise, we draw manually 3D spline in the middle of the pier as a vertical axis, which we will also select as a path for sweeping. In the next step, we will go to the building structure and switch on all the drawing files in which we draw reinforcement for the Pier 2. We can play now with visualization, and as a first step we will set the view type to animation, which is located in the right bottom of the screen. While being in the navigation mode, we can also right-click on the model and open the palette set surface, where we can modify the surfaces by setting the color, transparency and other parameters. It is also possible to go to the visualization task and the surface and light task area and use the tool Assign Custom Surfaces to 3D Architectural Elements. Here, under the Office folder, we can select different materials, for example concrete, and just drag and drop it to the selected 3D solids in the viewport. In the next steps, it is necessary to reinforce Pier 1 and Pier 3 by using the Sweep Bars Along Path tool in the same way we did for the Pier 2. After all three piers are reinforced, we will start with reinforcing the main girder. In the first step, as usual, we will set up the building structure. We will activate on the right side the sections drawing file, and we will also set to edit the main girder part with all drawing files. We will set up the preview to two viewports in order to see the 3D model together with the sections. We will use the same sections we created at the beginning of this webinar in order to create the reinforcement in the main girder cross-section. Before we start to draw the reinforcement, we will go again to the building structure and assign new drawing files to the structural level main girder. We will name the first file main girder reinforcement and set this file to active. After that, we will open the layer window with double right mouse click and create the new layer under the bridge folder and subfolder reinforcement with the name main girder reinforcement and the corresponding short name. This will be active layer in which we will draw main girder reinforcement. Under the default settings options, there are different settings which can be arranged. We will go to animation, and under the representation of engineering elements, we will set the surface color of the bar reinforcement, which will be taken from the diameter. The user needs to manually define different colors which will be assigned to different diameters. We will define here several diameters and assign to them different surface colors. After that, we will go to the reinforcement area where other parameters can be set, as for example standard for reinforcement or the concrete strength rate, which is used for calculation of different reinforcement parameters. We will work in the reinforcement with 3D model, and we can set here also other parameters. We can play with the representation of the bars. We can set different formats and colors of the bars for bar reinforcement, meshes and bar reinforcement placement. We can decide here about the predefined look of the labels which we will use later for the reinforcement labeling. In order to see the settings regarding reinforcement surface color, we need to go to the Show Height tool and check if color reinforcement in plan view is set to show. we can finally start with the reinforcement drawing. In the first cross-section which we made above the abutment, we already prepared some bar marks and draw some reinforcement, as for example open stirrups, straight bars, some free-form bars, and longitudinal bars shown as points. For the definition of these reinforcement bars, we use the bar shape tool and different shapes of bars which are offered in the list and also shown graphically. In the next steps, we will complement the section with additional reinforcement, and then we will place the reinforcement in the main girder. We will start by copying the existing bar marks of the longitudinal reinforcement by using the copy tool from the edit task area. We will copy the bars with using multiple copy function along the parallel line to the existing straight bar. In the next step, we will use the bar shape tool and draw a free-form reinforcement which will match the edges of the cross-section. We will use this tool in order to draw open stirrup with the width of the complete main girder cross-section. This stirrup will have the hook at start and at the end with the angle of 90 degrees. We will draw the free-form bar around the shape of the section, and when we finish with the definition, we will label the bar and escape the bar shape tool, since we will do the placement of the bars in the next step. It is always possible during the work to change the bar parameters afterwards by selecting the bar in the section and changing the parameters in the properties palette, like for example diameter of the bar. In the next step, we will place the bars drawn in the cross-section. For this, we will go to the free-form task area and use the tool Sweep Bars Along Path. We will again set in the Objects palette 3D Solids to Invisible in order to see only 3D splines which are automatically exported from Allplan Bridge. Those 3D splines we will use as a paths for sweeping the reinforcement. In the sweep function, we need first to select the bars in the section which we want to sweep, and then we will go to the 3D view, and by pressing the Shift key on the keyboard, we will select with the mouse Wish 3D splines, which will be used as a paths for this tool. We are free to rotate the model and change the views in order to easily select the Wish 3D splines. When all the paths are finally selected, we will escape the sweep function, and the bars will be placed along the bridge axis, following all the changes in the cross-section of the main girder. This demonstration shows the power of the sweep function and possibility of sweeping the reinforcement with just using one cross-section. Of course, if the user in the project has different bars which are changing from section to section with different dimensions and shapes, he would need to create several sections before he make the placement of the reinforcement by using the sweep function. After we make the wish changes on the model by adding transparency and also assigning the surfaces, we will go to the reinforcement task and place the full schema for some of the bar marks. This will show us the geometrical schemas of some bar marks, including the text with the description as a number and the length of the bars. This can be also placed next to the sections and used in the layouts. We will continue with reinforcing the bridge model and demonstrate the reinforcing of the abutments. We will start by going to the building structure and creating the new drawing files on the right side of the screen under the structural level sections with the name Abutment Sections. We will set this drawing file to active, and under the structural level Abutment 1 we will create also a new drawing file with the name Foundation Reinforcement. The complete structural level Abutment 1 will be set to edit mode. With these settings, we will start with the creation of the abutment sections. We will adjust the viewports so that we work simultaneously in the plan view where the sections will be made and in 3D view where we can see the 3D model. We will select the Create Section tool, and with the basic input we will create two orthogonal sections of the abutment. After this, we will go to the building structure and set the drawing file Foundation Reinforcement to active. By right double mouse click on the empty workspace, we will open the Layer window and define there the new layer under the folder Bridge and subfolder Reinforcement with the name Abutment Reinforcement and the short name. We will set this layer to active and we will start with the drawing of the reinforcement for the abutment. We will use the tool Enter Area Reinforcement and the input option Span Reinforcement in order to reinforce the pile cap of the foundation part for the abutment. For this, we need first to define the polygon with the wished offset, which we will enter in the command line, and then after escaping the function, new windows will open where we will define the additional parameters as the layer depth, concrete cover at the bottom, and other parameters. Since we want to place the area reinforcement also in the other direction at the bottom of pile cap, we will not escape the function completely, but we will press the match and then we will select already defined polygon and adjust all other parameters. The software will automatically place the reinforcement in orthogonal direction, and with that we finished with reinforcing the bottom layer of the pile cap. We will repeat the same workflow for the top layer of the pile cap and define the longitudinal bars in both directions by using the tool Enter Area Reinforcement and the input option Span Reinforcement. When we finish with the definition of the longitudinal bars and the dimensioning, we will go to the tool Bar Shape and select the Open Stirrup bar in order to define the stirrups around all the edges of the pile cap with user-defined spacing and diameter of the stirrups. With this, we finish with dimensioning of the foundation for the abutment, so we will go to the building structure and create the new drawing file with the name Wall Reinforcement and set again the abutment sections to active, since we need to define new sections for reinforcing the wing walls. Using the section tool, we will define additional section in the plan view of the abutment, and this section will go through one wing wall. Additionally, we will make another section of just defined section and place it next to it. We need both sections in order to properly define the bars in the wing walls. After this, we will go to the building structure and set the drawing file Wall Reinforcement to active and start with drawing the bars in the wall. We will select the Bar Shape tool and choose the straight bar. We will adjust the diameter and the concrete cover and place this bar with the option Expand to adapt the edges into the last created section of the wall. We will label this bar, but we will not place the reinforcement automatically. We will escape the tool and select the tool Special Placement in order to place just defined bar in the wall. We will select the wished bar by entering the bar mark in the command line or by selecting the bar in the section, and we will choose the input placement mode of the tool Placement in Polygon. After this, we need to define the section, and all the bar segments which will be intersected by the clipping line we will place will have variable dimensions. In the next step, we need to define the placing polygon. We will set a concrete cover in the command line and create a polygon in counterclockwise direction. After we set the benching placing direction in the command line, the special placement window will open. We will adjust here the number of pieces or the spacing between the bars and press OK. After that, the straight bar will be placed on one side of the wall according to our definitions. We will use the same workflow and the special placement tool in order to reinforce the other side of this wall. We will finish with the definitions and reinforcing the wall on one side and repeat the same for the wall on the other side and the perpendicular wall which is connecting them. Following different methods and using the tools shown in this webinar, we will finish the reinforcement definition and modeling of the abutment on one side, of the abutment on the other side, and all the elements until the complete bridge is reinforced. On this fully reinforced abutment, you will learn how to create schemas, bar legends, and reinforcement reports. We will go to the bar reinforcement task area and select the tool Partial Schema. Partial schemas are automatically updated if any changes occur to the placed reinforcement or bending shapes. After that, we will select the tool Full Schema, which includes all placements of selected bar mark, and changing of schema will automatically reflect any changes to placed reinforcement or bending shapes. To create a bar legend, select the tool Reinforcing Bar Legend. After that, select Bar Schedule Bending Shapes and make sure that Associative Legend of Active Document is checked. Created bar schedule includes all the bars from active drawing file. We will now use Stretch Entities tool in order to demonstrate how the changing of the bar shape in the full schema influences the change of the complete bar placement in 3D model as well as in the cross-section. Also, the changes are happening parallel in the bar legend. Under the task area Bar Reinforcement, we will select now the tool Reinforcement Reports. You can use this tool in order to create a report which includes mark-specific parameters such, for example, reinforcement, number of pieces, steel grade, diameter, and lengths. You are free to choose from a number of offered reports. The reports will be generated automatically and exported in PDF, Excel, Word, and other formats. As a last step of our webinar, we will go to the Annotations task area and select the Collision Check tool. You can use this tool to check if there are collisions between bar reinforcement, but also between different 3D objects, symbols, and other elements of the model. If the collisions exist, they will be highlighted and they can be also saved and exported in the file. When we correct the collisions, they will not be automatically deleted and the user needs to multi-select them and delete. With these last definitions, we are finishing today's webinar about detailing and reinforcement modeling in Allplan Engineering. Thank you for your attention and see you on the next webinar when we will show you how to produce drawings in Allplan Engineering.